triangle and you have to pronounce it del or delta. Okay, either you can pronounce it via delta or del. I frequently use this word del. Okay, so a del b can be written in this form: x such that x is belongs to a minus b or x is belongs to b minus a. And this is similar to something like union of two sets, right? The same thing which we have here, the diagram of a del b is nothing but a minus b union b minus a. So this is a minus b and this is b minus a, and you have to union it. Okay, so union it. So it will represent in this form. Got it? As we see the difference between a and b, a minus b is nothing but you have to remove b from a, and from b minus a is nothing but you have to remove a from b. Okay, so a del a. Okay, so or you can say a symmetric difference a or a del a. A symmetric difference a is empty, as you know very well, because if you a symmetric difference a means a minus a union a minus a. What is a minus a union a minus a? A minus a is empty, union empty. Empty and empty set is empty set. Okay, so a difference b and b difference a are similar. Okay, see, a minus b union b minus a is also the same thing as b minus a union a minus b. Okay, we can say this one. And the next thing is a difference b is nothing but x belongs to a union b and x does not belongs to a intersection b. See, the same thing happens here. All the elements whichever I have shaded region, just written the shaded region or the elements. Okay, these shaded region or the elements, x belongs to a union b, the whole a union b except a intersection b, right? So this one is a union b. See, this is a union b. Only the unshaded part is this one, and this one alone a intersection b, right? So none of the elements belongs to here, but all the elements belongs to a union b. Okay, so that means only the shaded region will cover a union b, and for a intersection b it will remain as a empty set. Okay, and this symmetric difference b can also be written as a union b removing a intersection b. That means only this part. Okay, like an apple. By removing that part, like an apple, you can describe that. Okay, a union b minus a intersection b by removing this part alone. Okay, got it? Yeah, let us have some important diagrams in set operations. You have to remember this thing in all the time. Okay, because in future also it is very useful. You have to remember these kind of diagrams. There are more than 10 diagrams which I will teach you, and you have to remember all those diagrams. Clear? Let us have this. So okay, let us have this exercise 1.3 fifth question. So state which pairs of sets are disjoint or overlapping. Okay, so disjoint or overlapping. Okay, so according to our given two sets, that means pair of two sets, we know already this set is overlapping set and these sets are disjoint sets. Okay, if they are separated by each other, they are called as disjoint set. So this is a disjoint set, and here this one is an overlapping set, because first set and second set are connected together and here disconnected. Okay, let us have this in mathematical manner. The question is, second question I'm gonna choose, second question. So C is equal to x such that x is a prime number, and that is greater than 2, that is 3, 5, 7, 11, 13, 17, 19, 23 and so on. Okay, these are all the numbers, and D is the given set x such that x is a even prime number. As we know, only one even prime number here, and state which pairs of sets are disjoint set. Okay, disjoint set or overlapping set. We need to confirm this. Okay, for disjoint set and overlapping set, we have a formula, particular formula for disjoint set. We need to check whether A intersection B is empty or not. Okay, for overlapping set, we have a formula, A intersection B should non-empty. Okay, any two set which is empty, we call it disjoint. Any two set, if you take intersection between any two set, that set is non-empty or not equal to 5, that set is overlapping. Okay, but here if intersection between any two set is empty, we say it is disjoint set. Okay, let us take the intersection between C and D. Okay, it is clearly seen that there is nowhere 2 present inside the set C. So if we take intersection of these two sets, clearly we will get empty. Okay, so in this case we say hence C and D are disjoint set. Okay, disjoint set. Got it? So in this way we can finish this 5th problem. Now let us move to the 6th question. So 6th question is, he's asking the symmetric difference. Okay, so 6th question is find symmetric difference between the following sets, and I have chosen the second set, capital R and capital S. Capital R is LMNOP, LMNOP, then capital S is JLNQ, JLNQ. Got it? So as we know, symmetric difference is nothing but it is this one, right? So this part is A minus B if it is A and B set inside the universal set. So this part is B minus A, and we know the formula, A symmetric difference B is nothing but A minus B union B minus A. Either you can write in this way or you can change it. Okay, yeah, let us do the problem now. So okay, let us see the solution. Or symmetric difference S is nothing but R minus S and S minus R. See, I have mentioned this in Venn diagram. So let us place the elements of R. So here's the one, M O P. I have just placed only the disconnected part. Okay, so M O P, and the connected part is L and N, which I have circled here, and in S we have to place these two elements only because the connected part is already joined. Okay, so R symmetric difference S is nothing but R minus S minus S minus R. So here I have mentioned only R minus S, which is in red. Okay, so R minus S, and this was S minus R. You have to either union it, or you can take A union B minus A intersection B. Let us take this union. So R minus S is nothing but MOP, and union S minus R is nothing but J comma Q. Okay, so this is it. This was your answer for 6th question.